Okay, in this video, we're going to look at problem 4D again. And maybe some of you don't like my approximate method of solving these problems. So what I'm going to do is I'm going to do the exact solution. Okay, so let's do this. And then what we'll do is we'll replace our zener with its model. Okay, so the model of the zener was this, if you remember. Rz equal to 20 ohms, and we get this voltage was 6.7 volts, which is Vz 0, right? So what is the output going to be in this case? Now, if this current is I, okay, and we say, okay, so if that current is I, what is the current flowing through the 2 kilo ohms? It's simply going to be V0 divided by 2K, isn't it? And if that is the case, what is the current flowing here? Iz. Now remember, I has to be equal to Iz plus the current through the resistance 2K, right? I 2 kilo ohms. But we've already written an expression for I 2 kilo ohms. Iz plus V0 divided by 2K. And this implies that Iz is equal to I minus V0 divided by 2K. Is that okay? Now what is I? Let's write I in terms of V0. It's going to be, what's the drop? The voltage here is 10 volts on this end of the resistor, and the voltage here is V0. So it's 10 minus V0 divided by 0.5K. So let's write that. So we have 10 minus V0 divided by 0.5K minus V0 over 2K. Now similarly, can we write Iz in terms of VO? Yes, we can, isn't it? Because what is Iz equal to? Whatever V0 is minus this voltage. So, okay, another way of saying it. What's the voltage here? 0, right? What's the voltage at this point? Just below this this voltage source here of 6.7 volts. What's the voltage here? It's V0, whatever the voltage is here, minus 6.7 volts. So therefore, what we get is V0 minus 6.7 divided by 20 would be Iz. Okay, so now we have an equation where the only variable is V0. And so we should be able to solve for V0. And if you solve the equations, you should get the value V0 is equal to 6.76 volts. Okay, so that's the exact solution if you were interested. Now let's compare this voltage with the voltage that we got from the approximate method. So here we have got 6.76 volts. And let's go back to this slide and where we use the approximate method. Oh, we have not really calculated the value here, isn't it? So what is that value going to be? 6.83 minus 68 millivolts is, it is 6.76 volts. And you can see that the approximate method and the exact method are resulting in almost the same solution. So there is a difference, but the difference is in the third decimal place. So which I think is all right, isn't it? So you could have used the approximate method in this case.